So here I've combined question 14 and 15 because they deal with the same function, and that is y equals 3 to the power of x minus 5. And so question 14 is asking us to find the domain of this function, and 15 is asking for the equation of the asymptote of this function. And so what I'm going to start out with is graphing kind of what this function will look like. So when x is equal to 5, the top part of this, or this exponent, sorry, is going to evaluate out to 0. And so 3 to the power of 0 we know is 1. So when x is equal to 5, y should be equal to 1. And then as x gets greater than 5, this exponent is going to be a positive number. And 3 to the power of positive number is going to get increasingly big as x increases. So this is going to go up quite quickly. And then as x, when x is less than 5, this exponent is going to be a negative number. And 3 to the power of negative number is going to be a fraction. So, and as x gets increasingly smaller, this is going to become an even smaller value for y. So what happens on this side is that this is going to get smaller and smaller and smaller, and it's going to approach 0, but it's never actually going to get there. Sorry, I seem to have lost my line here. It's never actually going to get to 0 because it's always just going to become a smaller and smaller fraction, and y is never going to be actually equal to 0. So that's kind of what our function looks like. And now we can think about what the domain is to answer question 14. So the domain refers to the possible x values for this function. And as we just kind of thought through this, we can see that x can actually be equal to any value. There's no limitations on x because as it gets greater than 5, this is going to increase, and as it gets smaller than 5, and even into the negative numbers, this function is still defined. So the domain for the possible x values is all real numbers. So that's the answer for question 14. Looking at question 15, the equation of the asymptote of this function is the equation of the line that this function approaches but never quite reaches. And as we've just said, this function on the left side is approaching the line y equals 0, or this x-axis, but it's never quite getting there. So we can say that this line here, the x-axis, or y equals 0, is our asymptote, and it's a horizontal asymptote. So our answer to question 15, the equation of the asymptote is y equals 0.